everyone. Thanks for coming. So good to be back in person. So this will be fun. Hopefully I remember how to do this. So I'm James Ward. I work on Kotlin stuff at Google, and this presentation is about the modern Java platform. So we'll be looking at some language features and then some things around the Java language, and then some Kotlin features, as well as a way to see some modern goodness that you can do in the Java ecosystem. So first, let's talk about modern, what that word means. So the way that I think about modern, when we say something is modern, is when it has made something easier to deal with increased complexity. So as we build systems, they're constantly growing in complexity. The problems that we're solving are getting more and more complex. And when we have tools available to us that make it easier to deal with that complexity, that is what I am calling modern. So an important thing about modern is that I see it as a spectrum. There are tools that are really modern and really far out. There are new programming languages. I'm interested in new programming languages like Flix. There's a language called Doll that I think is really interesting. So there's some things that are kind of on this like far end of the language spectrum, of the modern spectrum. And then there are things that are a little more attainable, things that we can get to with just a little bit of work, things that we can easily get into modern, something that has made that complexity easier to deal with, but isn't so far out, doesn't require us to do so much changing to how we're working or switch programming languages, that sort of thing. So modern, it's a spectrum, and I'm going to try to give you a little bit of a picture of the spectrum of modern in the Java ecosystem, but not go as far. If I had 3 hours, I would go into Scala and some of the interesting modern things happening in Scala, but we don't have 3 hours. We only have about 45 minutes, and so I'm going to just show you some things that I think will be attainable to most of you. So first I want to start with some Java 11 plus, so things that have been added since Java 11 or after, and walk through some of the language features that I would call modern in the world of Java. So let's start with an example here, which is records. So records were officially added in Java 17, I think is when it got finalized and given the thumbs up. And what records give us in Java is a Java syntax for creating immutable data types. And so this is an example where we are creating a record called point, and we give it the properties that are part of that point. And you'll see that the identifiers for those ints are x and y. So we've got our record, and this has some great stuff built into it. So this gives us immutability. Immutability is something that I like to rant about a lot because I think it's so important. It has totally changed how I build programs, the understandability of the programs that I build, the debuggability, the thread safety, all sorts of great things encapsulated in immutability. So these, when I define a record called point, you can see that I can use the constructor on it, like you may be familiar with, but if I try to override one of those property values, even IntelliJ is like, no, you can't reassign that. That is an immutable field on that record. And so for me, that's a really good thing because now I can share copies of this point around to other places. I don't have to worry about it being mutated from underneath me. And so I really like that records give us immutability by default. So records, concise syntax for defining our data types. You don't have to generate the toString, the equals, the hash code methods. Records just do all that stuff for you. If you're doing Kotlin, this is data classes. If you're doing Scala, it's called case classes. So this is a nice feature that is percolated into most languages at this point, is this concise syntax for defining our data types. So another nice thing in Java now is this type inference. So you'll notice that I am saying var here in front of point, and this is allowing me to not have to specify that type information on the left-hand side because the compiler can now infer the type from the instantiation on the right-hand side. So this, for me, is something that I use all the time, whether I'm in Java, Kotlin, Scala, use type inference, because to me it makes the code more readable. I don't have to have that duplicated type information on the left-hand side and the right-hand side. And so nice type inference there. The records have a built-in toString method, which we'll see in a second, which is really nice. And then another nice modern language feature is multi-line text fields. So kind of a little bit of a trivial thing, but definitely can help clean up code by not having to use plus signs at the end of the lines, and just makes multi-line text blocks a lot nicer to deal with. Okay, so let's run this hello records example, just so you can see the toString method on my record. Let's go check the output here. So this is the toString that the record just has built into it, and then you'll notice my multi-line text block there. I'm outputting the X and Y values. So simple example, but definitely something that I think is a great improvement to the Java language is the records, the text blocks, the type inference. So a lot of great new stuff, modern features in the language. Okay, before I go on from records, any questions about records? Yeah, go ahead. Yep. That's right. Yeah. So you're right that the new line is built into that. So this string that's being created here would have 4 new lines in it essentially. So yep. Yep. Yeah, for sure. Great. Other questions about records or any of this before I go on? So records were added in 17. I think that the text blocks were 17, but multi-line text blocks, but I'm not totally sure on that. Type inference, I think this was a while ago, so 11-ish, I think, was when type inference went in. Maybe wrong about that. Maybe somebody knows for sure. So I've stayed on the LTS releases for the most part, and so for me, 17 was the release when I could start using a lot of this stuff. Yeah, go ahead. Yeah, so these spaces, I think that they're actually included. I'll have to double check on that. There is, so in Kotlin's version of this, you actually call a method on the string called remove indentation or something like that, which will take out the indentation. And I can't remember for sure if Java includes the indentation. I know there's not a method to remove it, so maybe it doesn't. I'm not sure how that works in Java, but yeah, in Kotlin, it definitely includes that prefix spaces, and then you have to call a method to remove them. Good question. We could experiment with that later. Okay, so let's go on to the next one, which is definitely, I think this is something that we have seen all modern programming languages eventually get, which is under a wrapper called algebraic data types, ADTs. So algebraic data types are something that once you start using them, it changes the way that you model your data, and for the better. It's a really good thing. So there are usually 2 different algebraic data types that people use. There are product types and there are sum types. The product type it can kind of be looked at as a record. A record is, we can talk about it as a product type. So I wouldn't say it's 100% product type, but close enough for our uses. So there's the sum type, and the sum type is an algebraic data type, which allows us to use, we can think of it as using the logical OR. So in a sum type, we are saying a foo or a bar or a whatever. And the OR is creating a new type, essentially, that is the ORing of all those other types. So in my example here, I have a sealed, so this is the new part of Java, is the sealed interface, and you can seal different things. You can seal interfaces and classes, and I can't remember what else, but so I'm creating a sealed interface called robot. And then you'll see that I am telling it what my implementations, my possible implementations for robot are. I can have a vacuum robot, a snowblower robot, or a lawnmower robot. Now, because it's sealed, those are the only possible implementations that can exist for robot. And this is why it's an algebraic data type, is because the compiler knows that there can't be any other robots. There can only be 3 kinds of robots in my program because I've permitted them. There is a syntax where we can, instead of saying permits with the actual words there, we can just leave it as the default, which permits implementations only in this one file. And so that is the default behavior, or we can explicitly specify them. One reason why we would want to explicitly specify them is that then we can permit other implementations from other class files, from other files. Okay, so I'm all in the same file, so I didn't exactly need the permits here. But let's go see, all right, now we've got our vacuum, which implements our robot, and our snowblower, and our lawnmower. And so we've got our 3 implementations. So why are sum types so amazing? So it's really about how we interact with a sum type. So if we look down at an implementation here, we can see that, all right, the old way of doing things is we've got our robot, so that's our generic interface, and we can say, is it an instance of a vacuum? And if so, we can then cast it and then call a method on vacuum. So that allows us to do this type check. I think, let's give this a try. If I try to take this and say, hey, is robot an instance of a string? The compiler is like, no, it can't be, because robot can only be those 3 things that I specified. And so the compiler knows the constraints, the ors of the sum type, and so it's not even going to let me check to see, is this thing something that is not a robot? And so that is a really nice feature that helps us alleviate a whole class of bugs where we maybe are not checking for something or checking for the wrong thing, maybe trying to cast to the wrong thing. So I love ADTs. They've definitely changed the way that I program in a lot of good ways. But then there's some new syntax that I think is now final in 18. I'm still on 17, and I've enabled a preview feature. But this allows us to combine the instance of with the cast into a single statement. And so now I'm doing the same thing where I'm saying robot instance of vacuum, but you'll see that I'm specifying the type here on the right-hand side, and now I've given it my identifier v, and now my v, I can call the method on my vacuum. So this just gives us a nice syntax for being able to do that type check and then have a variable that is type checked and cast to that thing. So they call this pattern matching, which is a little bit confusing to me because in other languages, pattern matching is something a bit different, which I'll talk about in a minute. But this is, I think, final in 18 now. So then where this gets really cool is when we get into what I would call actual pattern matching. So now with switch in Java, you can use a sum type to do a switch on the different types of a sum type. And so now I'm doing a switch on my robot, and I'm saying, all right, if my robot is a vacuum, then I can get a identifier for it and call a method on it, and so on and so forth. But here's the really cool thing, is right now my switch statement is happy, but if I comment out my lawnmower line, now the compiler is telling me, hey, you did not cover all of the possible cases for robot. I know that robot is either a vacuum, a snowblower, or a lawnmower, and you forgot to handle the case where it's a lawnmower. And so this is where the power of sum types really shows itself, is when you have to do an exhaustive pattern match on all of the possible types that are included in a sum type. So really cool stuff. This, to me, makes my code so much better because then the compiler is helping me. It's helping me to know, oh, you forgot about this one case. And super nice. Definitely something that improves code quality in a lot of different ways. The one caveat to this, which we'll talk about in a little bit, is nullability. So what if, in this case, robot is null? Well, then my pattern match is no longer exhaustive. And I think there's currently a debate going on around whether they're going to require you to handle the null case in a pattern match for it to be considered exhaustive or not. So I think that is still kind of an open discussion. So, okay, so that's my sum types. Any questions on sum types? Yep. You can provide a default. So yeah, so I forget the syntax for it in Java, but you can provide the case that would match on all the unmatched cases. Yeah. Yeah, that's right. Yeah, then it would say your pattern match is exhaustive. So if you have a default, then yep, it'll always consider your pattern match to be exhaustive. Yeah, good question. Okay, let's see. I'm not going to run that one. We'll go on to the next one. So one of the nice things that got added in Java that I wanted to show off is around nulls. So I have a data structure here where I've got this like nested structure, and you'll see that in my second example, my plumbus is null. And so when I try to do something, when I try to call the plumbus.s method on that thing, it's going to blow up with a null pointer exception. But here's the cool thing that I want to show you is let's go run this thing and see the output. So now, I think this was added in 17 as well, but now I get my null pointer exception, but now I get this really nice null pointer exception message where it's telling me it.thing.plumbus is null. So it's telling me actually where in that call chain something was null. And so super helpful for debugging null pointer exceptions. So another great modern feature there in Java. Okay, so that is some of the Java language features that I would put into that bucket of being modern, and hopefully you can get onto newer versions of Java at your place of work and begin using these because there's a lot of good stuff in there. Let's now go on to the next part. So we've seen records, we've seen type inference, text blocks, sealed types, ADTs, pattern matching, and the null pointer exception helper. Oh, and then I forgot to show it, but I was creating a collection. Let's go take a look at that real quick. So there is now nice methods for creating collections. So you'll see I'm creating a set of, giving it my two things. So there's lots of now new helper methods for creating collections. And I think those were also added in 17. Okay, so we saw some of those language features in Java that I think are modern and great, and hopefully you can use. There's a few other things that have happened since Java 11 that I think are also pretty exciting. JShell, the new REPL for Java, I've used it a little bit, and I think it's great. It's definitely helpful when you just want to like test a quick expression or test something real quick. So JShell, nice REPL for Java, which something that a lot of other platforms have. Now we have it in Java, so that's great. Another one is Jpackage. So there's now tooling to create a distributable version of an application with the JDK, or with the JVM included in it, the JRE. And so Jpackage is something that I've used in a few places. I do a lot of server programming. There's a lot of different ways to kind of package up an application. We'll talk about that in a little bit. But Jpackage turns out to be a really good tool for assembling a package with everything that's needed to run a JVM-based application. So some other good tooling features. Okay, so if you want the code for the stuff I just showed, that's up on my GitHub under Modern Java Spring 1. Spring 1 because I first came up with this stuff for the Spring 1 conference. Okay, so now let's move on to kind of a broader step of modern, moving beyond the Java language to the Kotlin language is going to be some of the ways that I show some of this stuff. But there's a bunch of pieces that I want to show that are not about the language, are about the ecosystem around it. And so I'm going to use an example application to show some of this stuff, and we'll walk through it. But there's some different concepts that I want to illustrate. So to do this, I'm going to actually start out by running the tests for the application. So test-driven development, test-driven presentations. Let's start by running our tests. So let's do, let's see, Gradle W test. So I'm going to run the test for my application, and I'll show you the code behind it in just a minute. But what is going to happen, which is super cool, is this is a database application. It uses Postgres. And you'll see in the logs that it's actually going and spinning up a Postgres database for me as I run my tests, and then running my tests against that Postgres database. And you'll see that, sure enough, it was able to insert and retrieve some data out of the Postgres database. So this is using something called test containers, which is something that I hope all of you adopt. It is amazing, life-changing technology. What it does is it allows me to spin up Docker containers for services that I depend on. And it does it automatically. So it's managing the life cycle of the service dependencies that I have. It's managing that life cycle of spinning things up and shutting them down. It's managing that for me. It also supports things like parallelizable, so I can parallelize my test. It'll spin up a bunch of containers. There's a commercial service, I think I talk tomorrow about it, or maybe today, about a cloud service where instead of running those containers on your local laptop, you can run them on a cloud service. So really great stuff, and we'll see how we assembled it. But here's the cool thing, is that I used to, in the Java world, I used to use the H2 database for doing this sort of thing. So if I wanted to talk to a database, I wouldn't usually spin up an actual database. I would use H2, an in-memory database, and it gave me this nice experience. But the problem with H2 is that H2 is not what I'm running in production. H2 is definitely not what I'm using in production. I'm using Postgres or MySQL or Oracle or whatever in production. And so now I've got this disparity between the database that I'm using for local development in my tests and what is actually in production. Ideally, when we're doing local development or running our integration tests, we are matching the service that we're using locally with the one that is in production. That's the best way to alleviate bugs when it comes to integrations, is to have there be consistency between our environments. So we can use Docker containers as the way to create these services and run them. And you could just go and start up the Docker container for Postgres. I'm going to actually do that right here because I'm going to use it later. So I can go spin it up manually, and that's fine. But the nice thing about test containers is I don't have to think about spinning it up. I don't have to manage it. I don't have to, if I want to reuse containers, test containers are just managing the lifecycle. Where this gets really cool is when you have a graph of services that have interdependencies and have ports that need to be opened and that sort of thing. Test containers will pick a port for you. It will be able to orchestrate a tree of services. So in the case of the one that I worked with recently was KSQLDB is this service on top of Kafka. So I have a test container that needs to start KSQLDB, but KSQLDB depends on Kafka, and Kafka depends on Zookeeper. And so test containers just spins up all the Docker containers for all those things and wires the connection information across them because KSQLDB needs to know how to talk to Kafka, and I think there's even a metadata server that has to spin up as well. So a complex, not that complex, but a graph of services that need to be spun up, and test containers just does all that for me. So you could, of course, use Docker Compose, but Docker Compose is not part of your typical workflow. It is something external. You go run Docker Compose. Test containers, all I do is I run my tests, and it does the container management for me. Okay, so I love test containers. Really great part of the modern Java ecosystem. So let's go take a look at some code here for what I just ran when I ran those tests. So I'm using Spring Boot, and I'm using Kotlin, and I have this bar repo. So I'll go look at that bar repo in a second, but that is my way to talk to my database is through bar repo. I have a test, and my test is just going to verify that my bar repo works. So what I'm doing is I'm calling bar repo save, and I'm creating a bar and giving that to the save method. So that's doing the insert into the database, and then I'm doing a find all on my database. I'm making sure that I have one record in my database. You'll notice that I can stably test that I have one record in my database because by default, test containers is going to create a new instance of the database every time this test runs. So that's obviously has some overhead to it. So there is a downside for the way that I'm doing this here is that it does need to spin up a Postgres database every time it runs this test. You can reuse containers with test containers, but then this test would fail after running once. So some trade-offs there. You'd have to orchestrate your test to be a little bit different. Okay, so I'm doing my test, making sure that my count is 1, and I'm making sure that I got a primary key back from the database. So there's my test. Let's unravel some of this code a little bit. Oh, one thing you'll notice is there is nothing about the test container here. There's nothing about that Postgres database piece here. Test containers just manage that for me. The way that it managed it is if we go look at my application properties file that I use in my test scope, I'm telling my connection string for Spring to connect to R2Jdbc, TC is for test containers, Postgres, and giving it some information about my connection. And test containers has a way to, when this connection gets opened, it will then go start up that Postgres test container for me. And so that's how that lifecycle is actually being managed by test containers, is just through this connection string. There are a couple different ways you can start your test containers, but for this example, that's the way that I chose to do it. One more piece here is that I do need to, in my case, create the database schema. And so I just have this little component, Spring component, that initializes my database schema on post-construct, so on startup. So that was the only other piece that I needed to do there. And there's obviously lots of different ways to manage your database schema. Okay, let me show you in the Gradle build the dependencies here. So I've got a dependency on my test container for Postgres, and then I also have a dependency on R2DBC, which allows me to take that connection string and spin up the appropriate database. So that was really the only stuff here for test containers. Okay, before I go deeper into this code, any questions about test containers? Yeah. Great question. Yeah, so this example is definitely just Spring only. Test containers, I should say, works across all JVM stuff, and it even works on non-JVM stuff. So it will depend on how your test framework that you're using needs to start backing resources. So one way that I've done it with test containers in a non-Spring system is, like you can do before all and after all in JUnit. And so in my before all, I actually will say start this test container, and then in after all, I'll say stop it. Or it could be after before each and after each. But some way you will have to manually control the life cycle in your test framework, however that looks like for managing resources. But it's super basic. You basically just call start on the test container class. Yep. Yes, great questions. So absolutely you want to do this on your CI server in Jenkins or wherever. Use test containers, because that is giving you consistency between dev, test, your integration test, CI, and prod. You want to have consistency all the way through. So absolutely do this in Jenkins. And test containers manages the ports for you. So it will, I don't know how it keeps track of the ports that are in use, but it knows what ports are in use. And so if you can run multiple test containers in parallel, different processes, whatever, and test containers will select a different port for you, and so that you don't get port conflicts as it starts up those containers. That's right. Exactly. Yep. Yeah, really good stuff. And yeah, that port management piece is huge. And obviously in this case, I didn't have to specify anything in my connection string about the ports. And the machinery underneath here, specifically for Spring, is giving my Spring application the connection string with the port that test containers has selected. And so that's all happening for me automatically. There are other examples that I have where I do it more manually, and I start the test container, and then I have to get the port that was selected out and then map that into my database connection configuration. So you may have to do it a little more manually if you're not in the world of Spring. Quarkus also has great support for this if you're in the world of Quarkus. And this is something that I see the Java ecosystem continuing to evolve and leverage, because it just makes life so much easier. And so I think we'll see more testing support, more framework support for test containers as things go forward. That's right, absolutely. Yeah, so you don't have to use this particular, you can use a standard driver, you can use a standard connection string. You just, when you start your test container, you need to get the port out and pass it into that connection string. That's right. Yep. Yeah. Great questions. Yeah, go ahead. Using what was it? Yeah, so I've been using Postgres as an example here. Pretty much any service that you would likely use, there is already a test container for. So so there's Kafka, there's MySQL, there's like anything that is a Docker container can essentially be a test container, but they have out-of-the-box support for I don't know, 50 different services at this point. So lots of different services. Oh, client. Which client? Sorry. So like if you have a client and want to connect to that database. So when it starts up that Postgres container, it is just a Docker container running on, in this case, on your machine, my machine, with the exposed port. So you can connect to it just like you would any other Docker container. So yeah, absolutely. You can use any client tools that you want. You what? So I'm not familiar with that one, but it is just a normal database. It is just it's not anything that. How do you? So in my case, the way that I populate create my schema, which you could also in this way populate initial data into it, is I just run this command initdb run, which just runs a SQL. Which let's go find the SQL. So MySQL is very basic for this application. It's just running this SQL file. So there are different ways that you can bootstrap the data and schema that are in a database. This is the way I've chosen to do it for this application. If you're using Jdbc, there's actually an even easier way to do what I'm doing for database initialization, which is not supported yet by R2DBC, but. So it gets a little easier if you're in Jdbc land to do that bootstrapping. Yeah, good question. Sorry, I didn't understand it at first. Okay, so let's go back to our test and let's explore some other things that are going on here, which are pretty cool. So I want to first go into my my data class. So like a record in the world of Java, this is a data class in Kotlin. And one of the things that I want to point out is this type here, which is long question mark. And this is something that is an incredibly valuable feature in Kotlin. Something a lot of people love Kotlin for is this explicit nullability. So in Java, anything can be null. There's no way to indicate nullability in the type system. More modern languages, Java intentionally moves a bit slowly on some of this stuff. More modern languages have built the nullability information into the type system. So what long question mark is it is a nullable long. So it is only nullable types in the type system that allow a null value. And the reason why I made my ID null but not my name null is because if we go look at my test, you'll see that I don't have a primary key when I first create a bar. I get that from the database. The database creates the primary key for me. So I set the ID to null, and it is allowed to be null because I've indicated that in the type system, but my string here has to be a value. If I try to put null in that value, in that second value there, it's like, hey, that can't be null. That's not allowed. And so this is something that saves a lot of production bugs because now I've had to explicitly handle the null cases and do that and have the compiler check and verify that I've handled the null cases correctly. So this is something that I love and use all the time is nullability. Saves me a lot of production issues. And I'm sure that at some point we'll see Java doing this actually like in the type system. Obviously you can do it with annotations today and a variety of different annotations, but that's not a type system thing. And so what many modern languages have done is put nullability into the actual type system. Okay. So that's nullability, good stuff there. Let's go take a look at my bar repo. So my bar repo is, yeah, sorry, go ahead. Yep. 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 Yeah, so your list would be generic on a cat question mark. Yep. If you want to allow null cats to be in your list. So you would have to, your list would have to be list of cat question mark. Yep. Then it will not allow you to put a null cat into the list. Yep. And so the way that then, if you did have a cat null list, is that you could, if you're doing like a map transform on a list of nullable cats, you don't want to run your map function usually if the thing is null. So there are, in the case of Kotlin, helper functions that allow you to get the non-null stuff out of the list, and then you can do your map on it. So I forget what the method is, but you basically say like get all the non-null, filter non-nulls, and then you know that the next thing you do is going to be on list of cat, not list of nullable cat. Yeah, good question. Okay, so let's go on to the bar repo, which is the way that I connect to my database. So I'm using this thing in Spring called a coroutine CRUD repository. So this is what's giving me that save, that find all, other filter methods. I didn't have to write any code. Nice thing about Spring is I just create this interface bar repo, and Spring just does everything for me, which is nice. But here's one of the cool things, is that async programming is typically difficult, callbacks, and or you could get into monads and Scala, but async programming is typically hard. And I wanted to show you this because this is, I think, another kind of evolution of modern programming, is making async easier. So I chose to use this coroutine CRUD repository because I am underneath the covers using R2DBC, which is a non-blocking database driver for Postgres. So non-blocking. What this allows me to do is when in my case, a request is going to come into my REST server, and then I'm going to fire off a request to the database, there's going to be some amount of time where I'm just waiting for the database to respond with my query results. And so in that time that I'm waiting, the traditional way that what happens in J2DB, anyway, I'm confusing R2DBC with Jdbc. Okay, with Jdbc, what usually happens is when we're making that call to the database and we're waiting for that result, we are blocking a thread. It is a blocking call. It's a network call that just sits there and blocks the thread. So what we then have to do is have a big thread pool, and so that all these things are just waiting for stuff to come back. We're just sitting those into blocking thread pools. That is not the most efficient way to manage our resources. A better way is to fire off the request to the database and then allow that thread to go away and be used for something else. And then when the database response comes back, then go back to a thread, get back on a thread, and be able to return that response. Netty and Java NIO are the foundation for a lot of this non-blocking IO in the JVM. But it allows us to just more efficiently manage the resources that we have on our machine. But async programming is hard. I don't know if you've ever had to take a bunch of different asynchronous calls and deal with the possibility that some can fail, and how do you retry? Like async programming gets really tricky. And so one of the things that I think is great that Kotlin has done is they've made it so that async programming is like imperative programming. So I can be non-blocking, but not have to deal with the asynchronicity of the code. So if we go back to our test and look at this, so my bar repo save method, if we look at what this thing actually is, it is a suspend function. So Kotlin has special syntax called a suspend function that indicates that something is asynchronous. So what I'm doing is I'm calling the save method, but when I call that save method, the next line of code that runs, which in this case would be line 18, it does not actually run until the save method has come back, till that asynchronous call has completed. So this looks imperative. I write the code in an imperative style, imagining that there is nothing asynchronous, but underneath the covers, this is all non-blocking and reactive. So that's a really cool thing, modern way to do async programming without having it be this difficult callback-based or monad-based approach. And the reason why, you'll see up here on this line, why I call this run blocking, is that I've got all this asynchronous stuff, and Kotlin does need to know that hey, you've got a block of asynchronous stuff happening, that, different interdependencies of things. It needs to, in this case, be put into a blocking scope. And so this whole thing all the internals will be non-blocking, but the whole thing will now be on a blocking call. And for my test, I want my test to be blocking because I want my test to actually finish, before I say that my test is done. So the other, the way that we could do that, not in the case of a test, but if I just say, let's run this thing, then you'll actually see the compiler is telling me that, hey, save is a suspend function. This is an asynchronous function, and you have to propagate suspension, this async stuff that's happening, you have to propagate that out. And so I would have to say that this is a suspend function. So if I do want the whole thing to be non-blocking, then I have to say, hey, it's a suspend function. But in my case, because this is actually just a test, I want it to be blocking as a whole, and so I wrap it in that run blocking. Okay, so async, coroutines in Kotlin, really great way. Loom is going to give us a lot of the same functionality in the JVM, and I don't remember the target JVM ship launch number for Loom, but Loom will give us the same thing in the world of Java. So if you're not in Kotlin, don't worry, you're still going to be able to get this like imperative async without it being something you have to think about it with Loom. Yeah, question. Yeah, so it is all exception based. So you would do try catch on this code just like you would as if it was blocking. Yeah, so even though it's async, you're still doing try catch. It depends on your. This gets into the way that dispatchers work. So in Kotlin, coroutines are based on fibers. And so there is no, by default, guarantee that you're going to be on the same thread after multiple async calls. But there is a way that you can tell the dispatcher to trampoline the calls from fibers onto the same thread. And but definitely, I think to your point, dealing with stack traces in async, no matter what your async framework is hard. Because you lose the stack information as you hop from async context to async context. So that is not solved by this. It is async with stack traces is always hard and not useful. Like the stack trace is not useful in any async context. Yeah, good question. Okay, so we've got our non-blocking, which is reactive driver for the database. I want to show you the REST server real quick, just so you can see kind of how this comes together. So I've got my little REST server in Spring. You'll see that I'm doing a find all. That returns a flow. A flow is like a stream of async stuff. And so that is the flow there. Because it's a flow and in the world of coroutines and async, it has to be suspend function. Again, suspend function for my ability to save a bar because that save method is a suspend function. So what this means is that now my whole REST system, my whole REST server is non-blocking from the HTTP call through the database. So non-blocking all the way down, which is the way that we want to be. If you're only non-blocking on one part of a call chain, it's not that useful. Really, if you want to go non-blocking, best to be non-blocking the whole way. Spring also has, and many JVM technologies have non-blocking HTTP clients, so you can also do non-blocking all the way down with HTTP calls as well. Okay, so that's my REST server, and lots of good stuff with async and reactive in there. I want to talk about the next piece of this, which is containerization. So one of the things that I think is great in the world of modern Java is the ability, the ease of which we can turn our applications into containers. So for those that aren't familiar, containers are kind of the new way that we package up apps and then can run them on in different systems. We can run them in Docker locally, we can run them in Kubernetes. There are cloud services that you just give a container to and it will run it. So the container is this like zip file essentially of everything that is needed to run our application. It is the new way to have portability of applications across different environments. So there are many different ways we can containerize our applications in the world of Java. I'm going to show you the one that's built into Spring Boot, which is called build packs. And so let's just actually run it here. So I'm going to run gradle w, and then I'm going to say boot build image. And when I run boot build image, what's happening is Spring Boot uses something called build packs. Build packs are a Cloud Native Computing Foundation standard for taking different types of applications and turning them into containers. And build packs can work on Java, they can work on Ruby, they can work on Node, they can work on Go. There's build packs for everything you can imagine, but it's just a standard way to take an application, turn it into a container. So Spring Boot uses build packs to create our container, and it just did it, ran through the whole process to create our container. And so great, now my container is created, and now I can take that container and you use a repository to be able to kind of move containers around. So I could push this up to a repository on a cloud service and then have Kubernetes pull that container and start it up, that sort of thing. So build packs, they're great because they just make it so trivial to create containers. Let's go start up this container here. And so to start this thing up, I actually first need to, let's go to, yeah, we can run that one. So I need to initialize my database. So I have my database running, in this case, via Docker, and I've created this container image, Spring, Kotlin, Postgres, native. I'll talk about the differences here in just a minute, but I need to initialize my schema, so let's run this one. That just runs my Spring application, initializes the database. Now let's go and actually start my container. You'll see that now I'm using a different container, which was the one that was just created, but it's starting up my Spring application. And so great, now my application running on port 8080, connected to my database, reactive. Let's just go run a couple HTTP requests real quick to verify that this thing actually works. So I've got a post to localhost 8080 bars, and I'm giving it JSON, creating my bar with a name ASDF. Let's run that one. See, the response body is empty. That's good. That means that it inserted into the database, and now I can run my get, and we'll see that I now get back my JSON that has my bar that I just created with the ID that was assigned from the database. Great. So my server, it works. It's a Spring Boot application. It's reactive. It's in this case, I didn't use test containers. I do when I'm in dev mode, but I just started the Postgres container manually. Okay, so I've got my REST server all working, talking to the database. That's all great. But I want to show you the next cool thing in the Java ecosystem is that you'll see that this application on my laptop took about 3 seconds to start up. And you may have heard about something called GraalVM native image. GraalVM native image allows us to take a JVM-based application and ahead of time compile it into a native application. And one of the big benefits of doing this is that our startup time can be a lot faster because we're not relying on the JVM to start up. We're not relying on a bunch of classes to be loaded and read. It takes an application and just turns it into this ahead of time compiled application. So let me run the native version of this. And I already created the Docker container using build packs for the GraalVM native image part. But let me start this so you can see the difference. So that same application, same exact application, instead of starting in 3 seconds, started in 0.063 seconds. So a lot faster startup. If you're in a dynamic scaling environment like serverless, something where you're doing auto scaling, then the startup time can have a big impact. You don't want your user to like click checkout and then hit a cold start on the server, have to wait for that process to start up. So GraalVM native image, really great for dealing with the cold start issues that we typically have in the JVM. So I want to show you one other cool part of this is I've got those two container images, one that I pre-created, the native one, and then the other one. And I want to use this tool called Dive. And actually, let's just go up to this. So Dive is an introspector for container images. So this is the JVM-based, the default JVM-based container that was created for my Spring Boot application. You'll see down here, small print, hopefully you can see it. This is 276 megs because we've got the operating system, we've got the JVM, and we've got our actual application and the dependencies in there. And BuildPacks does a great job of layering those, and there's great caching with the layering in Docker. So like 276 megs seems like maybe a lot, but with caching, usually it's not too bad. But here's the cool thing is that when we ahead of time compile our application with GraalVM, you'll see that now my whole container image is 47 megs instead of that 267, whatever it was. So it's also a lot smaller because I don't need the JVM anymore. I don't need a big operating system. Like I can have this very thin operating system and just the binary essentially for my application. So lots of cool stuff with GraalVM native image. The one caveat to it is that it takes a long time to ahead of time compile a JVM application into a native application. So that's why I didn't run the build packs creating the native applications, because on my laptop it takes like 6 minutes to actually create that ahead of time compiled application. So there is a trade-off there. You should really only do that in CI, and so it's in a lot of production environments, doesn't have that much of an impact to have that long build time, because when you're doing local development, you're still running on the JVM. It's only when you create that like production artifact that you would create that native image. So, but it does take a while. It takes a lot of memory and stuff to do that. Okay, I think I'm about out of time, so we'll see if there's any questions. Yeah, go ahead. Yeah, great question. So for those that didn't hear, when you go asynchronous with your code, does it have any impact on your API definitions, like with Swagger? Does it have any impact on how you call those things? And there is zero change. So just because it's asynchronous, nothing changes with how your APIs are called. In the case of Kotlin, for using coroutines, they become suspend functions, but that's the only real change. And then on the caller side, it is just HTTP. So when I open a connection to my HTTP server, the client doesn't care that underneath the covers on that server that it is non-blocking and not using threads when it's in a wait state. It just is normal HTTP. So nothing changes from the caller perspective. It can be either one. It could be HTTP 1, 2, 3. It doesn't matter. It doesn't change the actual protocol. It just changes the way that threads get used underneath the covers for handling those connections. Yeah, good question. Okay, there's all the stuff that we went through. And then if you want the code for that Spring Kotlin Postgres example, that's up on my GitHub. So thank you all for coming. Hopefully that was useful. I'll be around if you have any other questions. So thank you. Good to be in person. Thanks.